Hey guys, we're going to run through our second part of the lesson for today. So just very quickly, shout out to Mickey. He told me that he couldn't stand my intro and decided to take it onto his own shoulders to make me my own special little intro. So I thought me being the superior YouTube channel would give Mickey a shout out and just say thanks Mickey for easing everyone's pain and finally giving me a proper intro. So today, what we're going to be looking at, or this afternoon, sorry, is simple interest graphs. So I want you to whack that down as your heading, simple interest graphs. So what we're going to be looking at in this lesson is how we can graph problems involving simple interest. So when we graph a simple interest graph, it shows us the growth of an investment over time, but we can also apply this to not only investments but depreciation. So before we get too far into it, when we're talking about depreciation, we're talking about something that we own. A car is always a good example. So the longer we own a car, the less value it's worth. A car will rarely ever be worth more than what it is when you first buy it, unless it goes full 360 and ends up being like a vintage car. So it's a similar idea with technology. So the older that a technology's been out, the less it's going to be worth. And the reason for that is because of depreciation. Lots of businesses, for example, the council, they would have a figure associated with a piece of machinery or something like that, and they would work out how much the value associated with that machinery drops each year. And this would be depreciation. So, a simple interest graph shows the growth of an investment. So, for example, a bank account. Or decay of an asset's value. And then I'll put in brackets depreciation. An example of this would be a car over a time interval. A simple interest graph will be a linear function because it'll be a straight line. And this means, if it's a straight line, that it will have a constant gradient. And that gradient's going to be the equivalent of the interest that we're calculating. Interest graph will be linear. Meaning it has a constant gradient. And then in brackets we'll say it'd either be the interest added or the amount the asset depreciates by, full stop. I think we'll jump straight into an example. So this will be worked example 9. This unit. And we've got Angel invests, we'll say $1,500 in a savings account that promises 5% per year simple interest. And we need to construct a graph that shows the amount the investment is worth over 5 years. Now the benefit to using a graph is that we can quickly see after 1 year how much is Angel's investment worth, after 2 years, after 3 years, after 3.5. Whereas if we're using the technique from the last lesson, we would have to break it down and work it out a heap of different times. So the first thing that we got to do is we've got to work out what is the gradient of our straight line. And remember, when we're talking about the gradient, we're talking about what is the interest of our straight line. So same process as before. Our principal is $1,500. Our rate is 5%, which we can also write as 0.05. And our T is going to be 1 year because we're interested in the gradient of our straight line, which is when we go across by 1 year, how much is our bank account going up by? So what we're going to do is we're going to sub this into our formula. Interest equals PRT, which is 1,500 times by 0.05 times by 1, which is equal to, put in your calculator, get an answer of $75. So meaning that when we go across each year, or as each year passes, we're going up by $75. Alright, now here's the table and graph I prepared earlier to save a bit of time. So what is happening with our amount is that each time we go down a year, we're adding $75. So after 1 year, we'll have $1,575, and then we'll have $1,650, $1,725, $1,800. Have I done that right? Plus 75, plus 75, plus 75, yep. And then $1,875. Alright. Now when we have a straight line graph, or a constant gradient, we only need 2 points. So I'm going to pick the two easiest ones. I'm going to pick this one here. So 0, 1,500. And then I might pick, no, I'm not going to pick that one. I'm going to pick this one right here. After 4 years, we've got $1,800. So I come across 4 years and I go up to $1,800 right about there. And then I'm just going to connect our straight line graph up with, there we go. Perfect. Alright, so as we can see now, with our graph, this is a measure of how much Angel would have in a bank account after 1, 2, 3, 3.5, 4, 4.5, 5 years of investing her $1,500 in that particular bank account. Now, next thing I wanted to talk about is depreciation. Now, I've written this out already, so we'll just talk about it very quickly. Depreciation is when an item that we purchase decreases in value over time due to wear and tear and age. And when an item drops in value by a constant amount, it is known as straight line depreciation, because that's what our graph looks like, a straight line. Sometimes companies will use different types of depreciation. As far as I know, in this course, all you need to know is straight line depreciation. But if you're ever in a position where you were looking at different types of depreciation, you would talk about it then. So when we're talking about depreciation, the value of whatever it is that's depreciating, so it might be a car, it might be an aeroplane, could be a piece of technology like a laptop, anything like that, the value is equal to, the initial amount, take away the initial amount times the rate times t, which is kind of like our simple interest, where we had the interest is equal to the principal, take away, or plus, in that case, PRT. So the initial P plus PRT, which is the interest. But of course, we're not adding up anymore. We're taking away, because we're talking about depreciation. So this is our rule right here. And last thing we're going to do for today is, we've got this worked example. So we've got a tractor and it depreciates by 9% per annum following straight line depreciation. As I said earlier, it's important to identify that it depreciates following straight line depreciation, because there's all different types of depreciation. And the question says, if the tractor originally cost $53,000, calculate its value after 5 years and show it on a graph. So I've prepared my graph here. But first thing we're going to do is we're going to outline all of our information. So our initial amount, or our initial value, which I guess is kind of like our P, is equal to $53,000. Our R is 9%, which is 0.09. And our T is 5 years. So when we sub into this formula from above, which is the value is equal to the initial amount, take away the initial amount times the rate, times by the time with brackets around it, which is important. I'm just going to shift this over to here. And then I will be shifting this down. So our value is the initial amount. It was a $53,000 tractor. Take away $53,000 times by 0.09 for our rate, times by 5 years. When you put that in your calculator, you get an answer of 53,000, take away bracket 53,000 times by 0.09 times by 5, which is $29,150. So again, when we're dealing with straight line graphs, which this is an example of a straight line graph, we need 2 points only. So our first point was up here. It was initially worth $53,000. And after 5 years, we found out that it was equal to 29,150, which I would place pretty close to halfway. Pretty close to halfway, right in there. And then of course we're going to connect her up. So close. Like so. So for our depreciation of our tractor, after 5 years, the tractor would only be worth 29,150 compared to the 53,000 that it initially cost. And if we were to graph what this would look like, it just looks like so, where every time we go across 1 year, it drops by, we didn't actually work it out, but it would drop by whatever 53,000 is times by 0.09 times by 1, which would be, bear with me for 1 second, 53,000 times by 0.09. So every year it actually drops $4,770. Yeah. So anyway, guys, through this lesson, I'll just go back to the start really quickly. We had a bit of a look at simple interest earlier in the day, and then we finished off this afternoon with some simple interest graphs. The main thing to remember is when we're trying to work out the gradient of our straight line, we use a time period of 1, because our gradient is every time we go across 1 in the x, or in this case the time, how much are we going up or down by. And then we finished with a real world application of this, which is depreciation. Alright guys, that'll do us for today. I'll see you next time.